morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and today we are listening to Elephant by Tame Impala, again from the hit CD Dave's Face, produced by the great Darby Foster. I said Dobby, I meant Darby. I suppose it's Dobby if you're from Boston, but it's Darby. So let's get to it, shall we? We are talking about the great sine function. Here we go. The basic sine curve. Here it is. So if we had P moving around a unit circle, we know our unit circle, we should, then we would be getting different values as it rotates around. For example, if you think that the x-axis is the angle measure in radians, so if this rotates pi over 2 radians, at pi over 2, we know that the sine of pi over 2 is equal to 1, creating the ordered pair pi over 2, 1. Here, if we rotated to pi, we create the ordered pair pi 0, because that is the distance of the angle in radians, and then we know that the sine of pi is equal to 0. So I found a video showing this, plotting the sine curve. Let me show it to you. It's right here. And just to explain what's happening, we've got the unit circle, and it's going to be rotating around starting at 0, this angle. And I'll stop it and explain it as we go. Okay, so look what's happening here. This angle, let me go back. Boom, you can see it. Right here, we're going to have an angle rotating around this circle, and then the graph is starting as it's going. Okay, so look here. At this angle right here, okay, they have 45.72 degrees or 0.8 radians. Then the sine of that is equivalent to the y-coordinate right here, yes? And so it's keeping, this part right here is keeping track of that for the value along the horizontal axis. As this keeps going, it's plotting all of the coordinates. So there it goes, boom. Okay, we just passed there. We know that the sine of pi over 2 is equal to 1, and that's where it hit right here. And now the values are going down as the unit circle is traced. And notice the height here. The height is equivalent to the y-coordinate that it's tracing. And the x-coordinate is equivalent to the measure of this angle. That's about 3 pi over 4 right here. 3 pi over 4. No, not 3 pi over 4. 5 pi. Yeah, 3 pi over 4, because this is pi over 4 here and then 3 pi over 4 here. There we go. And if we plotted all those wonderful points, this is where we would end up. So nice and so beautiful. Right back to 2 pi, and we know that the sine of 2 pi is equal to 0. So 6.28, that's about right. Let me go back to that. Yeah, here's the end. So it rotated all the way around. And remember, the x-axis was the size of the angle from pi over 4, pi over 2, pi, 3 pi over 2, all the way to 2 pi here, plotting those points. And we are going to do that by hand. So let's get to it. Let's talk about transformations. The basic form, or the general form of the sine function, is this. The coefficient a, then sine of a b times x minus c plus d. The a is going to affect the stretching just like in any other function, the a and the b. And then this is the horizontal shift, the c, and d is the vertical shift. A affects the amplitude, and the amplitude is the absolute value of A. Remember, that's the distance from the principal axis to the maximum point on the periodic function. We say absolute value of A is the modulus of A. Some folks call this mod A. It is the size of A and cannot be negative. B affects the horizontal stretch. A is vertical stretch, hence amplitude. B is horizontal stretch, and therefore it affects the period of the graph. The period is equal to 2 pi over B. Let's go back to this video. 1 period of the sine curve is equal to 2 pi before the graph starts to repeat itself. This is the basic sine function as we saw back here. 1 period of the sine function is from 0 to 2 pi, and then it keeps repeating itself forever and ever and ever. Okay. So let's graph it. Without the use of technology, sketch the graphs of y equals 2 sine x from 0 to 2 pi. So I got ourselves a nice little graph here. And we are going to start by sketching the graph of our basic sine curve. So you need to remember your unit circle, and it will come easy to you. Need to label our graphs, and notice we have some of the main points in our unit circle. Right here is going to be pi over 4, here's pi over 2, 3 pi over 4, and so on. So I'm going to go ahead and let this be 1, and this be 2, and then this be negative 1, and this be negative 2. Okay, so let's see. We know that the sine of 0 is equal to 0. So I'm going to plot that point here. I'm not worrying about 2 yet, the 2 sine x, just yet. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. And if we know our basic shape, we know that the sine curve, let's see how beautiful I can make it. That's a little off right there, so comes here, has a minimum down here, and right up to 2 pi. Okay. What does the 2 do to that? Well, the 2 just doubles our main values. 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, and 2 times negative 1 is negative 2, and then back to a 0. So, oh my goodness, start that over. It's just going to stretch it vertically, changing the amplitude. And there we go. So that's y equals 2 sine x. Couple of things here. Notice the amplitude of sine x is 1 because the principal axis, the x-axis, maximum point is at 1 from, so that is a distance of 1. The amplitude of 2 sine x, starting from the principal axis, which is the horizontal axis here, cuts the graphs in half, to the maximum point is 2, so the amplitude is 2. So we have an idea here that the amplitude is the value of A, but we got to investigate this a little bit first. So let's go ahead and do part B. Y equals negative 2 sine x. So I'm going to quickly sketch my sine curve again, just as a point of reference. Okay, and you'll be able to do this in your head very, very quickly. Here's 1, here's 2, here's, here's negative 1, and here is negative 2. Okay, so let's think about negative 2 sine x. So I'm going to multiply everything by negative 2. Y coordinate here is 0. Negative 2 times 0 is 0. Y coordinate here is 1. Negative 2 times 1 is negative 2. 0. Negative 2 times negative 1 is positive 2. Well, we should know this. We know that if we negate the entire function, it is mirrored in the x-axis, and then we're stretching it by a factor of 2. And so this becomes, loser time, positive 2 up here. Sorry about that. So we stretch this by a factor of 2, and it looks like that. So this is y equals -2 sine x, okay? And so the amplitude is still 2. It's always a positive value. The distance from the x-axis, from the principal axis to the maximum is 2. So the absolute, or the mod A, is the amplitude of the graph. Amplitude. Okay, so in this case, the absolute value of -2 is 2. That's the amplitude of -2 sine x. Okay, let's talk about the graph of the sine of 2x. Okay, well, the 2 is multiplying the x, meaning it's affecting the value of the function. I'm sorry, of the period. It's affecting the period, because instead of taking the sine of some value of x, you're taking the sine of 2x, okay? And that's going to affect the period. The period for sine x, the period is equal to 2 pi. And for y equals sine 2x, it's equal to pi. Period is equal to 2 pi over b. And what I mean by b is, remember, the general form of a trig function is a sine b x minus c plus d. So b is the coefficient of the x term, right? The coefficient here is 1. 2 pi over 1 is equal to 2 pi. The coefficient here is 2. 2 pi over 2, bam, we get a period of pi. Okay, meaning this nice little cycle repeats itself every pi units instead of every 2 pi units. So first I'm going to do sine x, okay, and hopefully by now you're seeing that I can always just do this as a guide. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, sine of 2 pi is 0, and that is my basic sine curve. I can sketch it as a guide or keep it in my head. Now, this same exact shape is going to repeat itself, but it's going to be scrunched in to a period of pi units instead of period of 2 pi units. So I'm going to do that in blue. Okay? So think about compressing this perfectly. So it's going to start here and it's going to end here, right? Well, the normal sine curve, halfway through, it hits 0 again. So halfway through on this compressed period, it's going to hit 0 again. And then the maximum occurs halfway between the two zeros, so that's going to be right here. And then the minimum occurs halfway between the last two zeros. Okay, so here we go. This is y equals sine 2x. And we're going to graph it from 0 to 2 pi. So that means I have to graph another period, another cycle, where it's going to repeat perfectly. So I can just punch in those points again. And there we go. So there we go. Y equals sine of 2x. So the amplitude is equal to 1, clearly. Distance from the principal axis to a max is 1. And the period is equal to pi, 2 pi over b. Okay. So there you have it. Hope you enjoyed it. That's part 1. Got a lot more to do with the graphing. We'll get that in a second video. And we will go back to elephant. Finish us up there. And with that, I am... Ooh!